Alex, I was staring at the back of my lathe yesterday, the big 220-volt beast, and I noticed this faint, rhythmic clicking. It sounded like a cricket with a grudge. Most people would ignore it, but when you spend enough time around humming motors, a new noise is basically the machine screaming for help in a language only some of us speak.
Or it's just a cricket, Tiger. But given your history with things melting, I'm guessing it wasn't a bug. Did you actually fix it, or are we about to talk about how you blew the transformer for the whole block?
My reputation precedes me, unfortunately. But no, I actually kept my eyebrows intact this time. It got me thinking, though, when folks move from simple woodworking or basic hobby stuff into bigger machines or industrial automation, the magic smoke becomes a very real, very expensive threat. We're diving into the deep end today, troubleshooting electrical and instrumentation systems without turning yourself into a human fuse.
It's a huge jump. Going from the light bulb is out to why is my PLC-controlled motor chattering like a set of wind-up teeth is a massive gap in knowledge. Where do we even start? Because I'll be honest, looking at a control cabinet full of gray wires makes my brain want to reboot.
It starts with your mindset, not your multimeter. Most people dive in and start poking. That's how you end up with a high voltage surprise. I like to think of it like detective work. You don't just arrest the first person you see, you gather the evidence. The E&I, electrical and instrumentation, world is about sensors, control loops, and power.
Okay, let's talk safety first, because I enjoy our podcast remaining a two-person show. I've seen those thick rubber gloves people wear. They look like they're for handling radioactive space rocks. Are we really in that kind of danger when we're just checking a motor?
Absolutely. Arc flash is no joke. It's not just a shock, it's an explosion of light and heat that can happen in a millisecond. If you're opening a panel on a large industrial system, you need the right PPE, voltage-rated gloves, face shields, and insulated boots. But the biggest thing? Lockout/tagout. If I'm working on a circuit, I want my own padlock on that disconnect, and I want the key in my pocket. I don't trust, I won't flip the switch, Tiger. People forget. Switches get flipped. Lives change.
Trust but verify feels like the understatement of the century there. So once you've locked it out and you're sure you aren't going to get crispy, what's the first actual move?
You've got to be a bit of a gossip, Alex. You talk to the person who was using it. I ask, what was it doing right before it went south? Did it smell like a burnt grilled cheese sandwich? Did it groan? Was there a lightning storm? You're looking for the history. Then you do a visual. I can't tell you how many complex electrical failures were actually just a vibration loosened wire or a contactor that's carbon tracked so bad it looks like a burnt marshmallow.
A burnt grilled cheese scent profile is surprisingly specific. So you're looking for the obvious stuff first. But what if the machine looks pristine? What if it's one of those ghosts in the machine where everything looks okay, but the motor just won't go?
That's when we pull out the Navy's 6-step method. It's a beautiful, logical ladder. You start with symptom recognition. Is it doing nothing, or is it doing the wrong thing? If a motor won't start, is it because there's no power, or because the control circuit thinks an emergency stop is pressed?
Wait, hold on. You mentioned control circuits. For someone used to a lamp cord, describe what that actually means in a shop or industrial setting.
Great point. Think of the power circuit like the muscles. It's the heavy 480 volt or 220 volt stuff that actually turns the shaft. The control circuit is the nervous system. It's usually lower voltage, maybe 24 volts, and it's the one making the decisions. If a contactor won't pull in, that's the big clack sound you hear when you hit start. It's usually because the nervous system is upset. Maybe a limit switch is stuck or a PLC output has gone to sleep.
So if the muscles are fine but the nerves are shot, the machine is effectively paralyzed. How do you find the break in the nerves?
You follow the breadcrumbs. This is where reading drawings becomes a superpower. If you can't read a ladder diagram, you're just a guy with a pointy stick. You look at the drawing, find the coil for the contactor, and work backward. Is the safety gate closed? Yes. Is the overload reset? Yes. Is the start button actually completing the circuit? You use your meter to find where the voltage stops.
I've seen you do this. You have this way of looking at a mess of wires like you're reading a novel. But for us mortals, what's a common gotcha that trips everyone up?
Single phasing. Man, I've seen this kill more motors than I can count. In a 3-phase system, if you lose one leg, maybe a fuse blew or a wire snapped, the motor tries to keep running on 2 legs. It's like trying to run a marathon on 1 leg and a crutch. It gets incredibly hot. It sounds like it's growling, and eventually the windings just cook. If your motor is running hot or tripping the overload, check your phase-to-phase voltage first. If they aren't balanced, you've got a one-legged motor.
See, that sounds like a logic puzzle. But what about the high-tech side? You mentioned instrumentation. That sounds fancy. Does that mean the machine is playing the violin while it breaks?
I wish. No, instrumentation is all about the sensors, pressure transducers, flow meters, thermocouples. In a modern shop or plant, the E and the I are joined at the hip. If a sensor drifts, meaning it thinks 100 degrees is actually 90, the control system will keep heating things up until you've got a puddle of molten lead where your casting was supposed to be.
How do you troubleshoot a liar? If a sensor is giving you bad data, how do you know it's the sensor and not a real problem in the system?
You cross-examine it. If the digital display says the tank is empty, but you can clearly hear fluid sloshing inside when you shake it, the sensor is the prime suspect. Or you use a calibrator to simulate a signal. You inject a 4 to 20 milliamp signal into the controller. If the controller reacts correctly, you know the brain is fine, and the I, the sensor, is the part that needs replacing.
It's essentially a process of elimination, but you've mentioned documentation before. It sounds like the most boring part of the job, but you swear by it. Why?
Because memory is a traitor, Alex. You think you'll remember that the blue wire on Terminal 4 has a tendency to wiggle loose every 6 months, but you won't. When I find a fix, I write it down in the shop Bible, my notebook. If I see a pattern of the same 50 amp fuse blowing on the CNC mill every time we run a heavy face mill, that's not a blown fuse problem. That's a process problem. Maybe we're pushing the machine too hard. Documentation turns accidents into data.
So, let's say I'm a hobbyist. I've reached the point where I'm buying a real deal mill or a lathe that isn't just plug and play. What's the one tool besides a basic multimeter that I should actually invest in if I want to stay safe and effective?
A non-contact voltage tester, the death stick, is great for a quick check, but for troubleshooting, get a high-quality Category 3 or IV rated true RMS multimeter. Don't buy the $5 one from the bin by the checkout. You want something that won't explode in your hand if you accidentally try to measure resistance on a live circuit. And get a set of alligator clips for your probes. Trying to hold 2 probes on tiny terminals while looking over your shoulder at a display is a great way to slip and short something out.
I've seen your concentration face when you're doing that. It looks like you're trying to defuse a bomb in a movie.
It feels like it sometimes, especially with chattering contactors. That's a classic. You hear click, 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 click like a machine gun. Usually it's just low control voltage. The coil tries to pull the magnet in, the voltage drops because of a bad connection, the magnet releases, the voltage goes back up, and it repeats. It'll burn a contactor out in minutes. If you hear that noise, hit the kill switch immediately. Don't wait to see if it settles down, it won't.
Okay, so we've recognized the symptom, we've looked at the drawing, we've measured the voltage, and we found the faulty part. We're done, right? We swap it and go back to making sawdust?
Not quite. The Navy Step 5 is failure analysis. You have to ask why it died. Did the relay fail because it reached its end of life? Or did it fail because there's a short in the motor that's drawing too much current? If you just replace the part without finding the cause, you're just feeding the machine expensive snacks.
Expensive snacks. I love that. It's like giving a mouse a cookie, but the cookie costs $100 and smells like ozone.
Exactly, and the final step is a full functional test. Don't just turn it on and say, yep, it spins. Run it through the whole cycle. Check the safeties, make sure the emergency stop still actually, stops things. I've seen guys fix a motor but accidentally bypass the safety limit in the process. That's a recipe for a very bad day.
It sounds like the overarching theme here is respect. Respect for the power, respect for the logic of the system, and respect for your own limitations.
That's it. There's no shame in calling a pro if you're staring at a VFD, a variable frequency drive, and the error code looks like ancient Sumerian. Those things are basically computers that happen to move heavy metal. But for most shop problems, if you stay calm, keep your hands out of the energized bits, and follow the path of the electricity like a map, you can solve almost anything.
I think I'm starting to get it. It's less about being a wizard and more about being a very patient accountant who works with volts instead of dollars.
That's a terrifyingly accurate description of my life, Alex.
So what's the big takeaway for our Tiger Den listeners today? If they're standing in front of a machine that just quit, what's the one thing they should remember?
Don't let the frustration drive the bus. When a tool breaks in the middle of a project, your instinct is to rush so you can get back to the real work. But troubleshooting is the work. Take a breath, get your notebook, and start at the beginning. If you treat the machine with a little empathy, trying to understand what it's struggling with, it'll usually tell you exactly what's wrong. Also, check the plug. I've spent 20 minutes chasing a ghost only to find out I tripped over the extension cord.
See, that's the Tiger we know and love. From master craftsman to did you check the plug? In 30 seconds.
Hey, I've paid high tuition to learn that lesson. Keep your circuits closed and your heart open, folks. We'll see you next time in the den.